Hello, this is Professor Sabatini at Passaic County Community College, and today in this video we are going to be doing Experiment 2 Density Determination for the Chem 103 class. Density is a physical property of a substance. A physical property is something that can be observed without changing whatever substance you're looking at into another substance. Some other physical properties of substances include color, odor, or melting and boiling point, things like that, where you don't actually turn the substance into another substance. You can just observe it as it is. The density is also an intensive property, which means that it remains the same regardless of how much material you have. If you have pure water in a 16-ounce bottle for drinking, it would have the same exact density if you had a whole swimming pool full of just pure water, right? It doesn't change because you have a different amount. The density is found by dividing the mass of a substance by its volume, and the units are usually given in grams per milliliter. Grams divided by milliliters, and that would be the density. So in today's lab, we are going to find the density of 3 different substances. First, we are going to find the density of a regularly shaped object. Then we're going to find the density of a piece of metal. And then we will find the density of a liquid. So in the first part, we're going to find the density of a regularly shaped object. And for that, we're going to use a ruler and math. The volume of a regular rectangle or a square is the length times the width times the height. So I'm going to measure all of these using the metric system because that's what we use in science. All right, so I'm taking this and I'm going to measure it in centimeters. So line up your ruler there, right? Measure it, and I get 3.7 centimeters for, we'll call that the width. So we write that down. Then I'm going to measure the length, 2.4 centimeters. Record all that on the data sheet. And then I'm going to measure, again, the height. Which is 2.3 centimeters. So if I multiply all of those together, I will get the volume. So the calculations will be explained on a different show here. All right, so that is that. Then I'm going to weigh this on the balance to get its mass. All right, so we went over, I made a video of how to use the balance. Make sure your balance says 0 in there. If it does not say 0, hit the 0 button. All right, and then I simply place my object on there, and I record the mass, making sure to write down all the numbers of the balance. Do not round the numbers. It says 12.893 grams. All right, so that is how you would find the density of that object. I would then calculate the volume, length times width times height, and I would take the mass and divide it by that volume. For the next part of the lab, we're going to find the volume of an irregularly shaped object, if you will. So how we're going to do that is by displacement. All right, so on the procedure, all right, you're going to go and put some water in this 100 milliliter graduated cylinder. Okay, so let me do that. Make sure there are no bubbles in there because bubbles mess up the volume, right? That's air, not liquid, so if they get displaced, that would change your volume. And then I'm going to put the graduated cylinder down and record the volume here. So what I want to do is, as you can see, the water in here makes a meniscus, meaning that it kind of is a concave shape there. When we're reading the volume in a graduated cylinder or anything, you're going to read the bottom of the meniscus, which is in the middle. So you always read the bottom. you also want to be at eye level when you're doing this. So what I can see here is it's in between 50 and 60, so it's 57, all right? And then I can estimate 1 decimal place. So right now I'm saying it's right about in between 57 and 58, so I'm going to call it 57.5 milliliters. So that's my initial volume of water. Then what I'm going to do is take my metal and carefully put that into the graduated cylinder. So I'm going to hold it like diagonally and slide it in there. Now, get rid of any bubbles, the volume has increased. The increased volume is due to the metal. So whatever the volume of the metal is, that's how much the volume now increased. So I read it again, no bubbles. And now it is about 64.8, we will say. So if I take this volume, 64.8, and I subtract the initial volume, 57.5, I get the volume of the metal. Now, I kind of jumped the gun there, and I should have actually weighed this metal first, but let's just pretend that I did that. So I'm just going to dry it off, right? You don't want the metal wet. So weigh out that metal first, if you were doing this at home. All right, and now I'm going to weigh it, right? So I have the volume, and now I have the mass, 19.504 grams. Okay, and that's the mass. Mass divided by the volume gives me the density. One other thing you might notice here is, well, not might notice, but could notice, I have 2 different pieces of metal here, right? And the density kind of, it tells you how heavy kind of something is of the same size. And I have 2 different metals. This shiny silver metal is aluminum. The density of aluminum is much lower than the density of brass, which is what this metal is. All right, so I can feel the difference, right? They're about the same size, but this brass is way heavier because it has a higher mass compared to its volume. So that's how you can say, like, kind of relate the density, right? Kind of how heavy something is. Okay, and that's how you would find the density of an irregularly shaped object. For our last part of the experiment here, we're going to find the density of a liquid. All right, now the liquid, the volume, is much easier to read because I'm just going to measure it in a graduated cylinder. So I'm going to take a smaller graduated cylinder, a 10 milliliter graduated cylinder, and I'm going to weigh it empty. Right, the mass of the graduated cylinder is 34.713 grams. Now I'm going to add a certain volume to that, let's say somewhere between 5 and 6 milliliters. Okay, now I'm going to record the volume again by reading the bottom of the meniscus at eye level. And this appears to be 5.98 milliliters. All right, again, on this smaller graduated cylinder, it goes from 1 to 10. The little graduated marks in there are the decimals, so it's like 5.8, 5.9, and then I estimated the last one because it's really close to 6. So I said 5.98 milliliters. Okay, so that's the volume. Now, to get the mass, I weigh this again. It's 39.665. And if I take this mass and subtract the mass of the empty graduated cylinder, I would get the mass of just the liquid that's in there. And then I could take that mass and divide it by the volume, and that would give me the density of the liquid in there.